In today's lesson, we're going to be solving a system of equations using matrices. So the idea here is we have here a system of equations we want to solve, and we want to put this in what's called a matrix. So to put this in a matrix, what we do here is we copy the coefficients of our variables down. So in this case here, the first equation, the coefficient will be 1, -2, -1. To signify an equal sign using matrices, we draw a line down our matrix. This is now known as an augmented matrix. And then across from the equal sign here, we see we have a 2. Now, had one of my variables not been here, let's say we didn't have the 2y or the z, you would have to put a 0 in that placeholder. Now let's copy the next row down. Copy the next row down, we get 2, -1, 1, and then it equals to 4. In the last row, we have -1, 1, -2, and equals to -4. So now what we want to do here is we want to get our matrix what's called upper triangular. To make this upper triangular, we want all of these entries to become a 0. In the top left-hand corner, this is a special entry in your matrix. It's known as your anchor. So all our operations and ways that we're going to make these entries 0 will be based on our anchor value. So for instance here, if I do the operation of row 2 minus twice row 1, right? You can see that written here. What that will do is it will take every entry in your second row. In this case, it'll start off with 2. It'll subtract twice this value, obviously making this 0. Then you go here, and this will take -1 minus twice this entry. Then we go here, and this entry will now be 1 minus twice this entry. And this entry here will be 4 minus twice this entry. So we're replacing the second row with the following operation. So I'm not touching the top row, so I write it down just as is. I am also not touching the bottom row, so I write that down just as is, and this becomes 0. Now, continuing on here, you take -1 minus twice -2. You're going to end up getting 3. Then we have 1 minus twice -1, which will also be a 3. And lastly, we have 4 minus 4, which is 0. Now, it's okay that we made this entry 0. Our main goal, though, was to make this entry 0, and we've done that. So now I want to go ahead and make this entry 0. So the way that you proceed is you start off in your first column. You grab your anchor. We made this entry a 0. Now we're going to go ahead and make this entry a 0. And then lastly, we'll move to this entry, giving us our upper triangular form that we wanted with 0s in these spots. So now I'm going to go ahead and take row 3, and I'm going to add that to row 1. Now you'll notice here I kept the first 2 rows unchanged, right? We weren't touching those 2 rows, so I just wrote them down exactly. And then the third row is replaced with just summing row 3 and row 1. So -1 plus 1 is 0, which was what we wanted. And then adding these up here, you get -1, -3, and lastly, -2 here. Okay, so now we've got 0s in these 2 entries. We want to now make 0 here. So once we do that, we change our anchor. So now my anchor is right here. This is my new anchor, and this is how my row operations will be performed. So now if I would like this to be a 0 here, to do that, I'm going to have to take row 3, and I can add that to 1/3 the value of row 2. And you can see here, if I take row 3 plus 1/3 row 2, obviously this becomes 0 because both entries are 0. This will end up being -1 plus 1, which is 0, which is what we wanted. And this entry here becomes -3 plus 1 when you multiply by 1/3, in which case you get your -2. And then the last entry here is also -2. So now we've achieved our goal. We're now upper triangular. So now we can convert this back to our system of equations. My first column represents my x's, my y's, my z's, my equal sign, and then my numbers. So converting this back to an equation, equation 1 is now 1x minus 2y minus z equals 2. Equation 2 is now 3y plus 3z equals 0. And equation 3 is now minus 2z equals -2. So you can see here what we can do now is I can go ahead and I can solve for z here, giving me z equals 1. I can sub that back into this equation, giving me 3y plus 3 times 1 equals 0, in which case here I get y equals -1. So now I have the values of z and the values of y, and I can sub both of those back into here to solve for our x value. So subbing these in here, I'm going to let y equal -1 and z equal 1, giving us x minus 2 times -1 minus 1 equals 2, in which case we get x plus 2 minus 1 is 2, and I end up getting here x equals 1. So the point of intersection of this system of equations is going to be 1, minus 1, 1. Let's take a look at another example. In the next example here, the same idea, we want to convert this to a matrix. So doing so, we get the following. You'll notice here that I put a 0 in this entry here. That's because for our first equation, there is no y variable, so the coefficient in front must be 0. Starting off here, we have our anchor at 1. Again, the goal is to make these entries here all zeros. So we're going to have to take row 2 minus twice row 1. And in fact, to get rid of this one here, we can do this on the same operation. This will be row 3 minus 3 times row 1. Doing so, we get the following. Doing so, our second row becomes 0, 2, 7, and 8. Again, performing row 2 minus row 1. And then doing row 3 minus 3 times row 1, we end up getting 0, 1, 7, and 11. Now we're going to go ahead and we want to have a 0 in this entry, so our anchor changes. This becomes our new anchor. And now I want to go ahead and make this a 0. So to do so, I can take twice row 3 and subtract that from row 2. We get 0, 0, 7, and 14. So you can see here we're now upper triangular, and now we can go ahead and convert this back to its equations. Keep in mind that your first column represents x's, second is y's, z's, and then we have our equal sign and then our numbers. So converting this back, we get x minus 3z equals -2. Second equation will be 2y plus 7z is 8, and the third equation is going to be 7z equals 14. So solving the system here, we end up getting that z equals 2. Substituting that into equation 2, we can go ahead and let z equal to 2. We end up getting 2y plus 7 times 2 is 8, in which case here we get 2y is 8 minus 14, y equaling -3. So now I know that z is 2, y equals -3, and I can sub both of those back into equation 1 to go ahead and solve for x. So doing so, we're going to let y equal -3, z equal 2, and we get x minus 3 times 2 is -2, in which case x equals -2 plus 6, and our x value comes out to be a 4 here. So you can see for this example, the point of intersection is 4, -3, and 2. Let's take a look at one more example. The next example here, same idea. We want to go ahead and convert this to a matrix. So our coefficients will be 1, minus 1, 1, 2. Then we're going to get here 3, 2, minus 3, and 10. And then 4, 2. There's no z value, so I put a 0, and then 16. So again, we start off with our anchor here of 1. We're going to go ahead here and do row 2 minus 3 times row 1, and this will be row 3 minus 4 times row 1. All right, you can see after performing these two operations, we now have a reduced matrix here. We want to take the entry here of a 6 and make that a 0. We have now our anchor of 5. So to do that, we're going to have to take row 3 minus, and this time it'll be a little more complicated. We'll have to take 6/5 row 2. Performing that calculation, we get the following. We end up getting here, for both entries, come out to be 16 over 5 and 16 over 5. So a little bit messy here, but you can see here now we can go ahead and put this back in our variable form with the x's, y's, z's, equal sign, and numbers. Doing so, we get the following equation. We can now go ahead and solve for z here. You see here that z equals 1. Subbing this into equation 2, we end up getting here, letting z equal 1, we end up getting 5y minus 6 times 1 is 4, in which case 5y is 10 and y is 2. And now that we have ourselves our z value and our y value, we can sub that in to equation 1. Subbing this into equation 1 will let y equal 2 and z equal 1. We end up getting x minus 2 plus 1 equals 2, in which case here we get x is equal to 3. So the point of intersection for this system is 3, 2, and 1. All right, that concludes today's lesson on solving using matrices.